If f is continuous over negative 1 to 1, show that the limit as h approaches 0 from the right-hand side of integral from negative 1 to 1 h over h squared plus x squared fx dx is equal to pi times f of 0. So first of all, we have to clarify this, that in this case, we cannot just first take the limit inside the integral, let h approaches 0. We get fx over x squared times dx. No, in this case, we cannot do that. The reason is because 0 is the potential problem here. Because if you treat the inside integrand as a two-variable function, g of h over h squared plus x squared, perhaps equal g of h and x, right? And this function, two-variable function, I think the other points are fine except 0, right? Near 0, 0, 0, it may not be continuous. It may not even have a limit. So what I mean by that is that if you treat h and x as a vector, right, here is the 0, 0, point 0, 0. Here is a point h, x, right, here's a vector. Now, it says hx approaches 0, 0. I can approach 0, 0 from any direction. I can approach in this direction, that direction, this direction, that. I can approach in a circular direction, right? Approach like this, right? Approach like this. So each different way of approaching will give me a different answer. So I claim that this two-variable function does not have a limit at point 0, 0. For example, if I approach it from to 0, 0 in the direction of x equal to, for example, let me use k times square root of h. H is positive from the right-hand side. So in that case, this will just become h over h squared plus k squared times h. Now, that is equal to 1 over h, and divide everything by h, plus k squared. As h and x both approach 0. So I'm talking about, in other words, as square root of h squared plus x squared, right? The length of this vector approaching 0. In other words, in this case, both x and h, right, h approaches 0, implies that x also approaches 0, meaning this also approaches 0. But if that's approaching 0, so this will approach 1 over k squared. Right, that is its limit as this point getting closer and closer to this point. Right? I mean, I'm like approaching this way. Right? So the limit in this case depends on the value of k. So meaning there's no limit. Right? If k is equal to 2 times square root of h, that will become 1 over 4. K is equal to 3, 1 over 9. So there's no limit. Right? Not to mention if I approach it from any direction. Right? From this direction, from that way, from this way, in this way. Approach 0. So that's why we cannot just take the limit inside here first. So to show that the limit of this is equal to that, first I assume that if f of x, f of 0 is equal to 0, what's going to happen? Right? All I need to show is that for any epsilon bigger than 0, can I find a delta? When h is smaller than delta bigger than 0, can I show the limit of this part, right, can be small enough? Negative 1 to 1. H over h squared plus x squared f of x dx minus 0 can be smaller than epsilon. Right, first, let me loosen the inequality a little bit. No larger than, I'm going to break it into 3 integrals. Right, absolute value of the integral from -1 to negative delta, where delta is positive. Right, plus integral from negative delta to delta, plus absolute value of another integral from delta to 1. Right. And of course, here I'm going to this integral. Right, for example, this integral, take the absolute value inside the integral, -1 to negative delta. H over h squared plus x squared. Right, this is already positive. Absolute f of x dx. So the motivation is because 0 is a potentially problematic point. Right? So therefore, to get around it, we just use delta small enough nearby 0. Right? This section and this section should be easy to deal with. I'll explain what this delta means. And in this case, f of x, right? And so maybe get rid of h squared, right? To make the denominator a little bit smaller, the whole thing become bigger. Right? So just this part, right? This part. Take out h. Of course, f of x has to be bounded. Let me just say, maximum of f of x, absolute value, x between -1 and 1, absolute value, because f is continuous over this closed interval. Right, so this closed interval, it has to be bounded above. Right, so this may be +1. Equal, denoted a big M, right? Make sure the whole thing is positive. Right? Because I'm going to do some division. So in this case, also no larger than M, right? M taken out. H times M, integral from -1 to negative delta, 1 over x squared dx. So this integral should be easy to solve. H times M -1 over x, evaluated from -1 to negative delta. Right? So I believe this should be negative delta, 1 over delta minus 1. 1 over delta minus 1. H times M 1 over delta minus 1 minus delta. Right? 1 over minus 1, yeah. So maybe get rid of the minus delta to make it a little bit bigger. Right? A little bit bigger. So how can I make sure this is small enough? Maybe as long as I let h, as long as h bigger than 0, smaller than a third of m delta epsilon. This epsilon is this epsilon. In that way, right? So this times m over delta times m over delta, m cancel out, delta cancel out, can be smaller than third of epsilon, right, in that case. So the same thing will happen to this section, right? Basically, basically the same, except I have to work out, evaluate from delta to 1, but basically it's the same thing, it's symmetrical. Right? Still can be less than third of epsilon as long as h is within this region. So how about this delta, right? So where does this delta come from? Right? Delta bigger than 0. So I say this delta is the delta that, given any epsilon, right? Given this epsilon, for example, right? Once given, I fix it. I can make sure that I can find a delta greater than 0, so that as long as x minus 0 absolute value is greater than 0, smaller than delta, I can always make sure that the absolute value of f of x minus 0 can be smaller than 3 pi epsilon over 3 pi. That's it, because that's the definition of the limit of at 0. Because it's continuous over this closed interval. So therefore, the limit as x approaches 0 has to be equal to f of 0 equal to 0. Right, exactly the definition. F of x minus 0 absolute value. Right, so fully taking advantage of the given condition. Right, as long as, that's the way I successfully get around the problematic point, 0. Right, so this negative delta to delta, as long as delta is very small enough, f can be small enough, right? So therefore, the middle section this time, negative delta to delta, h over h squared plus f squared, f absolute dx. Now, this time smaller than, first of all, epsilon over 3 pi. I'll explain why it's epsilon over 3 pi. And so just need to work out the integral from negative delta to delta h over h squared plus x squared dx. Right? But this is easy to work out. This is just epsilon over 3 pi. Negative delta. Factor out h squared. I also take out this h squared. And 1 over 1 plus h x squared dx. Right? That is equal to epsilon over 3 pi. 1 over h. Arctangent. X over h. Also using the chain rule, right? Just double check, differentiate that. 1 over that times 1 over h. Have to multiply by h, cancel 1 over h. Right? So this is gone. Evaluated from negative delta to delta. Right? So, but this arctangent delta over h minus negative, so it becomes plus, becomes twice of delta over h, right? Eventually. but arctangent delta over h, right, can be no larger than pi over 2, half pi, right? So no larger than half pi. Right? So 2 and 2 cancelled out. Pi and pi cancelled out. So this is in fact epsilon over 3. Right? That's why I chose epsilon over 3 pi. So that this section, right, altogether less than epsilon, right? As long as h is in this region, right? Epsilon given fixed, right? Once given fix it. Delta is dependent on epsilon, right? Also fixed. M, of course, also fixed, right? No problem. Right, so meaning I really found a delta. I say this is my delta. As long as h is less than delta, greater than 0. Right, this can be really smaller than epsilon. Right, so meaning the limit of this is really 0 if f of 0 is 0. So what if f of 0 is non-zero? If it's a, right, what's going to happen now? Then I can just construct a function g of x equals fx minus a. So that way g of 0 is equal to f of 0 minus a, which is equal to 0. Right? F minus 0. So g of 0, I can apply the previous conclusion, right? If f of 0 is 0, this is true. Right, so meaning this negative 1 to 1 h or h squared plus x squared times this time g of x should approach 0. Right, but that means negative 1 to 1 h squared plus x squared. G is f of x minus a. Right? This will approach 0, which means integral from negative 1 to 1 h over h squared plus x squared f of x dx minus integral from negative 1 to 1 h times a h squared plus x squared dx. The whole thing approaching 0. Right? So this one should be easy. Like, in fact, I've already worked out previously. Right? This should be equal to a times arctangent. I think it's twice of, if I remember correctly, twice of arctangent of x over h evaluated from negative 1 to 1. So I think it's twice 1 over h. So whole thing approaching 0 as h approaches 0. But as h approaches 0 from the right hand side, this approach positive infinity, arctangent positive infinity, half pi, right? So this approaches a times pi, right? Half pi, 2 and 2 cancel out, a times pi, as h approaches 0. Right? But the whole thing approaching 0 already. So this can only approach something minus a pi approaching 0. This has no choice but to approach a times pi. Right? But what's A? A is f of 0. Really? It's really true.